Hi friends, see today we'll be starting the chapter Thermal Properties of Matter part 2, that is called as heat transfer. Okay. In this chapter in MCEPT we will get around 1 to 2 marks, and in NEET examination you will be getting around 6 marks hardly. In MCET 1 to 2 marks maximum, and in NEET examination hardly you will be getting around 6 marks. So first of all, in introduction, what are the modes of heat transformation? Okay, let us see what are the main modes of heat transformation. In general, heat can be transferred in 3 ways. 1. Conduction. 2. Convection. And 3. Radiation. So heat can be transferred in 3 ways. One is conduction method, convection method, radiation method. So let us see what is meant by conduction method. See, in conduction method, for example, all metals if you take very good conductors of heat and electricity, any metal, iron, steel, aluminium. Suppose at one end, suppose if you heat it, after a few minutes, you can see the heat is transferred from this end to other end gradually. That means what is happening here? Inside the atoms are there. These atoms will be vibrating, and the heat is transferred from one point to another point due to vibration of the particles inside the rod. So in this way, the heat is transferred from one end to another end by the method of conduction. So that is why whenever we catch hold of any metal rods, after a few minutes you can see the feeling of heat, okay, either at A end or B end. Now let us go with the next method, heat, that is convection method. Right? So now this next case, that is convection method. So if convection method lo chuddam how the heat is transferred from one place to another place. See, the best method of convection method lo em jarugundante, now suppose for example, see, a small bowl is taken, fill some water. Now when you heat this water, what happens is, you can see after some time some molecules are coming down, water molecules, and some molecules are going up. So why this is happening here? After some time some water molecules are coming down and some water molecules are going up. What does it mean? That means when the water molecules gets heated up, the density becomes less and it goes up. And on the top portion, the water molecules which is having higher density, that is cooler molecules of water, will come down. Again they get heated and they go up. So in this fashion what happens is, the hot air also you can see in the rooms, okay, in bathrooms also you can see some exhaust fans are kept. So the hot air is exhausted by using the exhaust fans. So here what happens, during the convection method, the heat can be transformed from one place to another place by the method of convection. ఈ మెథడ్ ఆఫ్ కన్వెక్షన్ ద్వారా ఏం జరుగుతుంది, మనకి హీట్ని ఒక ప్లేస్ నుంచి ఇంకో ప్లేస్కి మనం ట్రాన్స్ఫర్ చేయొచ్చు అన్నమాట. దట్ ఈస్ ద మెథడ్ ఆఫ్ కన్వెక్షన్. సో ద మెయిన్ మీనింగ్ ఈస్ the density becomes less. For hot air you can see the density is less, therefore it escapes from the exhaust fans or from the ventilators of the building. And heavier molecules, which are cooler molecules, not only this one, the best example you can see in the summer season, will be opening the windows. When you open the windows, the cool breeze from outside, because of heavier density, enter into the room. And the hot air or waste carbon dioxide or hot air, what happens? It goes away and escapes from the ventilator. So that is the next method of mode of transfer of heat. And the last one is radiation method. The last one is radiation method. Let us see the last method. లాస్ట్ మెథడ్ మనం ఇప్పుడు చూద్దాం. మనం రేడియేషన్ మెథడ్ ఎలా హీట్ ట్రాన్స్ఫర్ అవుతుందో. ఓకేనా? రైట్. So let us see the last method. See, in the last method, if you observe carefully, radiation. What is meant by radiation? So in the method of radiation, no medium is required. No medium is required. That means heat can be transferred directly, just like sunlight. Even in vacuum it can transfer, just like electromagnetic wave. Okay? Just like electromagnetic wave, light waves, heat can be transferred without any medium. Even when in vacuum also it can be. The best example is the sunlight for radiation method. What is the best example? The best example is sunlight. That is the method of radiation. Okay? Right. So we have discussed about 3 types of transfer of heat. That is conduction method, convection method, and radiation method. Now we'll get into the next topic of this chapter, that is heat transfer. That is, what is the definition of coefficient of thermal conductivity of a given material? Coefficient of thermal conductivity, okay, of a given material. This is generally indicated with the letter K. Okay. For this one, what we'll take is, we'll take a small material or metal rod. Okay. This is end A. This is end B. Let the temperature here be T1 degrees Kelvin and here T2 degrees Kelvin, and make a note, T1 is greater than T2 or T2 is less than T1. Okay? So you can observe from the figure lo chudandi, T1 degree centigrade is greater than T2 or T2 is less than T1. So here one thing you have to make a note, steady state and unsteady state. Steady, what is meant by unsteady state? That means when you give the heat to this iron rod, continuously the temperature will be changing over. That means T1, T2, and also even the middle I can take theta degrees Kelvin. Okay? So here the temperature, for example here 20, 10, 5 degrees. Again 30, 15, 10. But after some time what happens? It attains steady state. So when it attains steady state of heat, what happens? No more heat is given. That means it maintains constant. Here T1 degrees Kelvin, here T2 degrees Kelvin, here theta degrees Kelvin. Absolute temperature. Now to define coefficient of thermal conductivity of the material, what happens is, the quantity of heat flowing in this conductor is directly proportional to temperature difference delta T, and it is also directly proportional to time small t, directly proportional to temperature difference, that is T2 minus T1, which is a higher temperature. It is also proportional to time, that means more time, more heat transfer, and it is inversely proportional to length of the conductor. Inversely proportional to the length of the conductor. Let us combine all these equations. ఈ 3 equations combine చేద్దాం. Q proportional to delta T small t by L. Not only these, one more parameter is also taken into consideration, that is Q proportional to A. This A is called as area of cross section of the material. If you consider that also, what happens in the equation? Q proportional to A delta T into small t by L. A is the area of cross section, pi r square or pi d square by 4. L, length of the conductor. Okay, length of the conductor. T1 and T2 temperatures. Okay, E and the temperature ఎంత ఉంది T1 degrees, I and the temperature ఎంత T2 degrees centigrade. So these are the temperatures. Now if you remove the proportionality, introduce a constant. Proportionality తీసి ఒక constant పెట్టండి. K A into delta T into T by L. Please note down these equations. They are very important. Right. Now you observe carefully. We got an equation for coefficient of thermal conductivity of the material. That is, see, Q is equal to, that means quantity of heat flowing in a conductor of length L, area of cross section capital A is given by this thing. Now I will substitute and change the equation as Q into L by A into delta T into small t is equal to K. This is the exact formula for coefficient of thermal conductivity K. Q, heat, you can take it in calories or joules, MKS unit, length in meter, area, meter square, temperature, degree Kelvin, time, seconds. But we know this meter and meter gets cancelled. Joule per second is nothing but watts. Therefore, the MKS unit is watt per meter degree Kelvin. Therefore, the SI unit of coefficient of thermal conductivity is what? Watt per meter degree Kelvin. Clear? Please note down. Very, very important equation regarding MSET and NEET, because regularly they will be asking around 6 questions, 6 marks it will be there in NEET, and in MSET 1 to 2 marks you will be getting. Okay? I will note down the equation. So the unit is watt by meter degree Kelvin. If you want, you can also write the dimension formula also for this one. If you want, you can also write the dimension formula. See here, Q, that means heat, M L square T power minus 2, just like work done, length L by area L square, temperature degree Kelvin, time T. Sometimes temperature is also written as theta, dimension formula, okay, or K. Now see here, L square cancel, and if you write in proper way, ML power 1, M power 1, T if you take it to the top, T to the power of minus 3, degree Kelvin power minus 3. Sometimes this one is also written as theta, but you can take it this one. So M power 1, L power 1, T power minus 3, okay, and K power minus 1. That is the dimension formula for coefficient of thermal conductivity. Please note down. Okay, right. Now let us go further into this chapter. So let us summarize first of all before going. Till now we have learned about in this chapter heat transfer, that is mode of transfer of heat by conduction method, convection method and radiation method. ఈ మూడు మెథడ్ ద్వారా మనం హీట్ ఎలా ట్రాన్స్ఫర్ అవుతుందో చూసాం. నెక్స్ట్ థింగ్, కోఎఫిషియంట్ ఆఫ్ థర్మల్ కండక్టివిటీ ఏంటి అనేది డిఫైన్ చేసాం మనం ఒక గివెన్ మెటల్ రాడ్కి, విచ్ ఈస్ కెప్ట్ ఎట్ టెంపరేచర్ T1 degrees Kelvin and T2 degrees Kelvin. అంతేకాకుండా మనం డైమెన్షన్ ఫార్ములాస్ కూడా ఇచ్చాం మనం కేకి, దట్ ఈస్ కోఎఫిషియంట్ ఆఫ్ థర్మల్ కండక్టివిటీకి, ఓకే, అండ్ SI units also are given for that one, okay. So these are the things we have learned till now. Now let us see now what is meant by heat current. What is meant by heat current? See, already we know in second year we are having current electricity. So in second year current electricity, what all you have learned about current? See, let us remind for that one. In current electricity we learned what is current. Current is given by potential difference by electrical resistance. You can see here. In secondary electricity, electric current, strength of electric current is given by potential difference by R. Ohm's law. This is V is equal to IR. In the same fashion, here also what is meant by heat current? Heat current ante enti? Rate of flow of heat, which is also called as power. Rate of flow of heat is equal to, already I have given an equation, K A delta T by L, isn't it? Because the original equation is Q is equal to Ka into delta T into T by L. If you divide with the time T, then this is called as heat current or power. Sometimes it is also called as power. Rate of flow of heat is also called as heat current or power. Heat current or power. So when you match this one with the above in current electricity formula, you can change in this way. This heat current, I will write it here. I will rub this one. See here. I will write it here. The same equation can be transferred in this way. The same equation I can transfer in this way. See, this heat current Q by T, I can write it as capital H. This capital H is nothing but rate of flow of heat is equal to, now see this one, I will change this equation, delta T by R thermal. See here. Now see, this is the equation for heat current, that is temperature difference by thermal resistance, and in current electricity Ohm's law, potential difference by electrical resistance is electrical current. See, both are almost equal. So here in the terms of R thermal, H is equal to delta T by, what is R thermal here? You can see here. R thermal means, I can write as, see, L by Ka. See here. R thermal resistance, I can write as L by, because Ka, it will go to the numerator now. So Ka by L. So this is another expression we will be using in numericals of this numericals in this chapter. Okay. So finally, we have defined what is heat current when comparing with current electricity, electric current. Okay. That is temperature difference by thermal resistance. Where thermal resistance RTH is nothing but L by Ka. L is length of the conductor, K is coefficient of thermal conductivity, and A is area of cross section, which is nothing but pi r square. Okay. Now, let us see when conductors are connected in series. When conductors are connected in series, what will be the effective coefficient of conductivity? Okay. Let us see. Series connection of conductors. Let us see now the series connection of conductors.